Okay, yeah, so now we're ready to go.
Okay.
Go ahead.
Oh, all right, this is our project. You have our circuit for our switch. This is our home switch here. When this motor sends it all the way down the track to this part here, it closes a switch here, which tells the chip that it has now reached this position. This is our capacitor that we use to time the actual, I guess, motor position.
Well, the motor position command, which is on a variable resistor over here. See it?
Right here.
Yeah, so there's a variable resistor over here on the board, and what we're really doing is measuring the position of that resistor in order to determine where the carriage should go. So we've got a linear carriage with a slide. It's hard to see the slide, but there it is. Yeah, right there. And the slide can move back and forth. It's driven by the stepper motor. Stepper motor is being driven through the amplifier right there by the basic stamp. Okay, so go ahead.
All right, so what it's going to do basically is as soon as you initialize the program, it's going to automatically go to home so that now the basic stamp knows where the motor position is, and it's going to be right here.
Yeah.
When it does that, it closes that switch and resets the program. So from there, it'll read the resistor and go to whatever position that resistor tells it to be at. And from there, you can change the value of the resistance, and it'll move. Yeah, it'll move accordingly. So I can go ahead and reset it, and you'll watch it go home.
34. Okay, so about 35.
And it comes back to right where it was.
Because that's the position of the resistor.
And then I can change the position of the resistor,
You
and
can
it'll
see the
move to
carriage
that.
move and track to it.
One of the problems that we had was when it was at a certain point stopped right now in the code, it had a lot of noise in it. This track would jiggle back and forth because there was a little bit of slack in the resistor. So it's now we had to change that to be accurate to within one or two different positions.
So you basically added a section in your code that says if the command position and current position are different by more than one step or so, then
Then
we need to move.
If
Otherwise,
not,
just sit
it's
there.
acceptable.
Yeah.
So
There's some allowable error.
And right now it's within one position, and we tried it with two, and it was just about the same. We couldn't really get any noise within one position, so it seems to be all right.
So some of the challenges you have to overcome, as I recall, was that the number of steps to move the carriage from one end to the other extreme was unknown. So you wrote a small program to figure that out.
And it
count the
ended up
number of
being,
steps.
I think, 288 steps from here to here.
Now, was that full steps or half
That was
steps?
full steps. So with half steps, it was 560 something.
Okay. Okay, so you took the number of full steps, multiplied by 2 to figure out, and so I remember you changed your code from full stepping to half stepping, and that made the carriage move even smoother.
Exactly, and I think this is half stepping right now.
Yeah.
So
It's 576.
yeah, 576 half steps from here to here.
Okay.
So.
Okay. Now, the original system this came out of was an old dot matrix printer, right? Okay, so all we did was yank apart the dot matrix printer, found a nice stepper motor. It was a simple, technically a 6-wire, but I think they hooked 2 of them together, so this was a 5. Was it a 5 or? This
Yeah,
was
well,
a
you had your 2
6-wire.
center taps. We just wired the center taps both being grounded. So
Yeah, so a 6-wire and a 5-wire work out pretty much the same way, where you just wire your 2 center taps together to ground.
and it's just running off, I think, 15 volts.
Yeah, in fact, we found that on the end of the motor, there was a label that told us how many volts the thing was supposed to run at, so that made that part easy. Some of the motors are marked well, some are not marked well. So basically what happens in summary is, as you move the resistor from one extreme to the other, the potentiometer from one extreme to the other, the carriage just tracks that as a position. So the resistor represents a position that the carriage should move to, and it does it. Okay, thank you guys, I appreciate it.
Not a problem.